Welcome. You know, right beneath your daily human experience, beneath your moods, your energy levels, and even how you age, there's this hidden biological operating system quietly running the show. In this explainer, we're not just looking at another list of simple health hacks. No, we are diving deep. We're going to decode the invisible machinery that literally dictates your reality every single day.
Let's start with a massive question. What invisible biological forces are actually shaping the quality of your life? We've all been conditioned to view health as this rigid checklist, right? Diet, exercise, sleep. Check, check, check. But science reveals a much more elegant truth. Your body is one deeply interconnected system. To master it, we have to uncover the invisible forces that sync it all up. And to do that, well, we have to confront a pretty fascinating biological paradox.
24.2. This number represents a massive, unexpected puzzle discovered by chronobiology researchers. See, your body doesn't actually run on a perfect 24-hour clock. It averages 24.2 hours. That means, without any external input, your internal clock naturally drifts about 12 minutes later every single day. If you were left in total darkness, your systems would eventually spin completely out of sync with the Earth's rotation. So, how do we survive this? How does the body constantly recalibrate?
Section 1. The eye's secret sensor. There's this stark, almost unbelievable contrast between what we think our eyes do and what they're actually doing in the background. Beyond your classical vision, the rods and cones detecting images, shapes, and colors, there exists a tiny, highly specialized subpopulation of cells. We're talking less than 5% of your retina. These are called iPRGCs. And here's the crazy part. They don't see images at all. They are irradiance detectors. They are literally measuring time.
So how do they do it? Well, these cells use a slow, sustained photopigment called melanopsin. Now, unlike the fast-acting cells that help you read, melanopsin completely ignores quick flashes of light. Instead, it acts a lot like a biological hourglass, integrating and measuring cumulative brightness over time. It actually peaks in sensitivity to the blue light spectrum, exactly what you'd see in a morning sky. It gathers all this ambient data just to signal the time of day to your brain. But that raises the question, where exactly is this signal going?
Section 2. The Master Biological Clock.
Okay, let's trace this. When morning light hits those secret sensors in your eye, the signal travels at lightning speed along a dedicated neural highway called the retinohypothalamic tract. It completely bypasses your visual cortex. Instead, it shoots straight into a microscopic cluster of cells deep inside your brain, unleashing an electrical pulse that dictates literally everything your adrenal and pineal glands do next.
That microscopic cluster of cells, that's the suprachiasmatic nucleus, or SCN. This right here is your master circadian pacemaker. Think of the SCN as your body's ultimate conductor. Every single cell in your body, your liver, your heart, your skin, they all have their own individual clocks. The SCN communicates with every single one of them via these complex neuroendocrine pathways to ensure your deeply interconnected systems are perfectly timed with the Earth. If this master conductor gets out of sync, the whole biological orchestra basically falls apart. This brilliantly illustrates the biological seesaw the SCN manages. In darkness, the SCN permits the synthesis of melatonin, that's your sleep hormone, through a multisynaptic sympathetic pathway. But the absolute millisecond that bright morning light hits those iPRGCs, the SCN triggers a rapid sympathetic suppression. Melatonin production is instantly, almost violently shut down. Sleep is chemically shattered by light. But hey, stopping sleep is only half the equation, right? What actually ignites your waking state?
Well, simultaneously, that same morning light triggers something called the cortisol awakening response, or CAR. Now, cortisol often gets a really bad rap as just the stress hormone. But in the morning, this 50 to 100% surge within your first 15 to 45 minutes of waking is not a stress or panic signal. It's a vital metabolic primer. It gets your energy systems online and clears away sleep inertia so your cognitive function can actually peak. As you can see visualized here, the difference is absolutely massive. Transitioning from a dim room into bright, early morning light actively creates the physiological conditions for easier waking. It massively spikes this vital hormone. You're not just reluctantly dragging yourself out of bed, you are biochemically igniting your day. But the impact of this single morning event echoes way, way beyond breakfast.
Section 3. The hormonal ripple effect.
We really need to talk about the phase response curve because it proves that in biology, timing is literally everything.
Exposing your eyes to light is like pressing buttons on a biological remote control. If you get bright light late at night, before your biological temperature minimum, you delay your clock, pushing your sleep cycle later. But light immediately after waking advances it, keeping you tightly synced. So, getting light at the wrong time, it literally pushes your entire biological schedule out of alignment.
This is exactly why world-leading neuroscientists like Dr. Andrew Huberman emphasize that morning sunlight exposure is absolutely vital. It is not just some trendy wellness hack. It's the fundamental recalibration of your entire internal timing system. In fact, getting that morning light actually sets a roughly 16-hour biological countdown timer for your melatonin release later that evening. Think about that. Your deep sleep tonight is literally being programmed by the light you see this morning.
When you respect this biology and establish a rhythm, it's incredibly powerful. Look at this timeline. At 7 a.m., bright morning light initiates that cortisol spike. By 2 p.m., you're experiencing sustained daytime alertness while cortisol naturally begins its gradual decline. And then by 9 p.m., a dim light environment triggers the onset of melatonin. When you operate this way, your nervous system easily shifts from a sympathetic, active state during the day to a deeply parasympathetic, recovery state at night.
But contrast that beautiful, aligned rhythm with our modern reality, things like shift work, midnight screens, or spending days in dim, indoor environments. The long-term consequences of this chronic circadian mismatch are, frankly, staggering. It heavily dysregulates your cortisol and melatonin. And this isn't just about feeling a little tired. This chronic misalignment silently reshapes your health trajectory, heavily increasing your risk for metabolic and mood disorders over time.
And right when science thought it fully understood this system, a totally counterintuitive finding emerged. It turns out, not all of the specialized light sensors go to the master clock. Distinct subpopulations IPRGCs bypass the SCN entirely. No way, right? They wire straight into your limbic system, the emotional center of your brain. That means light has a direct, hardwired pathway to instantly elevate your mood, regulate your core body temperature, and boost alertness. It is literally a biological wire connecting the sun to your emotional state.
Section 4. Reclaiming your biology.
So, let's pull all these incredible interconnected benefits together. The overarching realization here is profound. Health is not a random collection of separate, isolated habits. Health is the emergent result of countless interconnected biological processes occurring every single moment of every day. By aligning your light environment, you're optimizing everything, from deep sleep and stress regulation to metabolic health and cognitive longevity. You are finally taking the controls of your hidden operating system. You now understand the invisible biological forces shaping your life. You've seen how light dictates hormones, how hormones dictate mood, and how mood fundamentally alters your biological trajectory. So having seen all of this, the only question left to ask yourself is this: how will you choose to shape your light environment and program your biology when you wake up tomorrow morning?